Topic number 1.2, states of matter. This world is made up of matter and energy. Energy is non-material in nature. Anything other than energy which carries mass and occupies some space is called matter. Matter occur in many distinct forms. We observe four states of matter in everyday life: solid, liquid, gas and plasma. Apart from these, there are more states of matter which we do not see in our daily life. The three primary states of matter are the solid, liquid and gases. They are different from each other due to different strength of intermolecular forces, the arrangement of particle and the distance between the particle. If we discuss gas, in gases, molecules are very widely apart with no order and very weak intermolecular forces. All these features make gases easily compressible. Their densities are very low. Then we move toward liquid. On the other hand, liquid have molecules which are closely attached but moving randomly. There exist significant intermolecular forces between their molecule. Liquid are therefore not easily compressible and their densities have higher values than those of gases. Then move towards solid. Solid have a definite shape and a fixed volume. Particles in solid are closely packed and have very strong intermolecular attraction. The particles in solid remain fixed at their position where they can oscillate about their mean position. Solid are relatively incompressible and rigid. The densities of solid are very high. Solid are the only state of matter which do not need any container to be stored. In crystalline solid, particles perfectly arranged and strongly bonded. This makes them almost incompressible. They are the most dense substances. Plasma is not so generally seen form of matter. It is composed of particles with very high kinetic energy. It exists in fluorescent tubes, lighting and welding arc. Plasma can be considered as partially ionized gas containing electrons, ions and photons. Matter also exists in intermediate states where liquid meet gas and liquid meets solid. For example, supercritical fluid, liquid crystal and graphenes. Supercritical fluids are highly compressed states which show both properties of gases and liquid. Chemical reaction which may not be carried out in conventional solvent may possibly carried out in supercritical carbon dioxide. Liquid crystal is a state of matter whose properties are between those of conventional liquid and those of crystalline solid. Liquid crystal are used in display devices including computer, monitor, clocks, watches and navigational systems. Graphene is an example of two-dimensional crystal, a single layer of carbon atom arranged in a hexagonal pattern. Graphene is a tough, flexible and light material with a high resistance. States of matter that are not commonly encountered are called exotic state of matter. Examples are dark matter, Bose-Einstein condenser, nuclear matter, quantum spin liquid and many others. Topic number 1.3, element, compound and mixture. As we know that matter has anything that has mass and occupies space, that is known as matter. Matter in this world exists in the form of element, either compound and mixture. Element is the simplest form of matter. It is a pure substance containing the same kind of atom. It cannot be broken down into simpler substances by ordinary chemical reaction. Element exist in all three forms: solid, liquid and gas. Most of the elements found in this world exist in solid form. Liquid and gaseous elements are very few in number as compared to solids. Element may be metal, a non-metal, a metalloid and a noble gas. Element can also exist in the form of atom, molecule, ions and isotopes. Example of important elements are sodium, potassium, magnesium, calcium, carbon, silicon, nitrogen, oxygen, chlorine, helium, copper, gold, zinc, silver, nickel, bromine and iodine, etc. Compound is also a pure substance. It is made up of two or more different chemically element combined in a fixed ratio. When the element come together, they react with each other and form chemical bonds that are very not easy to break. Compound may be molecular, ionic, intermetallic, and coordination complexes. Compound may also be inorganic and organic in nature. Example of important compounds are water, ammonia, methane, carbon dioxide, sodium carbonate, potassium chloride, starch, protein, carbohydrates, mineral acid, organic acid. The composition and properties of an element or a compound are uniform throughout a given sample and from one sample to another. A mixture is formed when more than one type of element or compound are mixed together in any ratio. Air, milk, and tap water are everyday example of mixture. A mixture may be homogeneous and heterogeneous. A solution of salt and water is an example of homogeneous mixture because its concentration is uniform throughout. A sample of rock is an example of heterogeneous mixture because the concentration of its constituent is different in its different parts. Rocks are composed of different types of minerals such as granite, mica, and limestone.